Welcome to the Data Hall YouTube channel. In this video, we're going to talk about how do we test correlation or apply correlation in R. There are different types of correlation. So we are going to discuss Pearson correlation, spearman correlation, the Kendall-Tau correlation, and then we are going to, these are the correlations that we apply on numerical data, continuous data, and then we have categorical correlation related to categorical variables, where we would see at Tetrachoric correlation, then we would see at Polychoric correlation, and we are also going to discuss how do we do listwise, casewise, and pairwise deletion or correlation. So let's start with Pearson correlation. This is the mostly applied correlation. So we apply this on the continuous data. What we do is we use the first, let's load the data. We are going to use the iris data that contains the length and width of different flowers and their species. So we are going to work with the length and width of these two columns. So when we do Pearson correlation, we use the CUR function, and let's apply this correlation on all the data. So what we do is we use the iris data frame. We do not select any columns or rows. So all the rows would be taken and column 1 to 4. So let's apply this on column 1 to 4. And we are going to apply the Pearson correlation. So if I apply this, we can see that we have got the correlation, and this is the correlation between sepal length and sepal length. So that means it would be 1 because it is the correlation between itself, the variable itself. This is the correlation between sepal width and sepal length, and we can see this is the correlation with petal length and sepal width, sepal length. So this is any value greater than 0.7 would be considered a high correlation. Any value between 0.3 and 0.7 would be considered moderate correlation, and anything lower than 0.3 is considered a low correlation. Also, when we talk about correlation, there is no dependent or independent variable. This is just an association between two variables. So we cannot say that petal length would have an impact on sepal length, or sepal length would have an impact on petal length, but it is just an association between these two variables. So there is no dependent or independent, there is no causality. We are just looking at the correlations, associations. Let's say we just want to do the correlation between two variables. So we would select the first variable and the second variable, and the rest of the command would be exactly the same. Apply this, and we get that the correlation between sepal length and petal length is 0.87. This is what we got over here. That is the positive correlation. Next, let's move to spearman correlation. And spearman correlation applied when we have certain ordinal data or ranks in our data. So again, the only change that we would do is instead of the word Pearson, we would use the word spearman, and the rest of the command would exactly be the same. So we get that the spearman correlation is 0.88 between these two variables. But we can also get the significant test, the significant values, whether this correlation is statistically significant or not, and that is what we get using this line of code. The only difference is we use the exact is equal to false. The rest of the command is same except for the function also, because now instead of correlation function, we are using correlation test. And this is the p-value that we are interested in. If p-value is less than 0.05, then we would reject the null hypothesis, which suggests that there is no correlation, or the correlation between these two variables is equal to 0, and the alternate is that the correlation is not equal to 0. So we reject the null hypothesis in favor of alternate hypothesis, and that means that statistically speaking, we are statistically significant that there is a positive correlation between these two variables. So a p-value less than 0.05 suggests a significant correlation. Let's move to Kendall-Tau, and Kendall-Tau is also used when we have an ordinal data. The rest of the command is exactly the same. We just change the word Kendall, and we get the correlation and the p-value also. So this correlation test would give you the p-value and as well the correlation value, right? So if you are interested in the test statistics, then just apply the cvar.test function. So we can also see that it is statistically significant. So let's move to correlation of categorical variable, where we are going to use the Tetrachoric Correlation, and for that we are going to load the psych library. Now I have already installed this library, but if you haven't installed it, then you would install it using install.packages and specify the name of the library that you are going to load. Press Ctrl Enter and it would be installed, but I have already installed it, so I am just going to comment this out. So let's load this library. The library is loaded. We are just going to create a table that would contain a matrix that would contain certain data. So this is how the data looks like. We are going to apply the correlation on this data. Let's assume that is certain categories, right? So we just use the word tetrachoric and then the function tetrachoric and then specify the data that we want to apply it on. And this is what we get our correlation. Then we have polychoric correlation. Now this is applied when we have more than 2 or more ordinal categorical variable, right? So there should be ordinal, some order in the data, right? The categorical values rather than just being different categories. For example, gender is just category, there is no order in that. So we would use the Tetrachoric Correlation. But if we look at the customer satisfaction or service quality, then there obviously 5 is either more or less customer satisfaction, right? So there is it is an ordinal data. So let's just create this data. So I have created 2 vectors, that is customer satisfaction and service quality, and I want to look at the correlation between these two variables. So I use the function polychoric, and then specify both the vectors or columns if your data was in a data frame. Press Ctrl Enter and we okay, so I haven't loaded the library. For that we are going to use the polychoric library and press Ctrl Enter and we get the correlation. Last we are going to discuss the listwise or pairwise correlation. So listwise and casewise is one in the same thing. Listwise means that what we are going to do is we just apply the correlation on the data where where all the observations are available, right? So for example, if we have 4 columns and so if data is missing in any of that column, then that specific row would be excluded if we use listwise or casewise. So let's generate some data, right? And let's input. So we have customer satisfaction, product quality, and sales performance. These are randomly generated data. Let me show you this data. So these are certain numbers. It is numerical data, continuous data. And let me introduce some missing values, right? So we have introduced some missing values in our data set. So what I'm going to do is I'm going to apply the listwise correlation. And for that, what I'm going to do is within this correlation function, I'm going to use the use parameter and specify complete observations. That means where all the data is available, and that would apply the correlation. If I were to do pairwise correlation, that means apply the correlation when like for example, when it is going to apply the correlation between customer satisfaction and product quality, then we just need to include the rows that contain the data for both service quality and customer satisfaction. This is what we call pairwise. So for each pair, we should have the data. So the number of observations that we would have for this specific correlation, the correlation between product quality and customer satisfaction, would be different from the number of observations that we have for the, let's say, sales performance and customer satisfaction. So this is what we call pairwise deletion or pairwise correlation. We just use the pairwise word and the rest of the command is exactly the same. Let me press Ctrl Enter and we get the pairwise correlation. So I hope this was useful. Do subscribe to this channel and do hit the bell icon.